All right, let's get right into it. If you've ever tried building a modern full-stack app with an AI coding assistant, you know how quickly things can get, well, messy. You start with this great, simple idea, but before you know it, you're trying to wrangle a front end, a back end, a database, and an AI that's doing its best but keeps getting tripped up.
And that's really the million-dollar question, isn't it? How do we bring some order to this powerful new way of building things? How do we actually guide our AI so that it builds what we have in our heads and does it consistently and correctly across the entire project?
So let's take a super common example, a simple to-do app. You can add tasks, check them off, delete them. Easy. But then you think, hey, I want to access this on the web. So you need a web interface. And that interface needs to talk to a back-end API. And that back-end needs a database to actually save your tasks. All of a sudden, your simple app is a full-blown, complex project.
So how do you handle that jump in complexity? Well, you do it the same way you'd build a house. You start with a blueprint. You would never just walk up to a construction site and tell the crew to, start building a house. You'd give them detailed architectural plans. And that exact same idea applies right here. We need to give our AI a solid plan to follow.
And that blueprint, that plan, has a name. It's called spec-driven development. The idea is actually pretty simple, but it is incredibly powerful. Before the AI generates a single line of code, you write down exactly what the software is supposed to do, how the API works, what the database looks like, all of it. These detailed specs become the one and only source of truth that guides the entire build.
This breakdown really nails the difference. The old way feels like a constant back and forth. You ask the AI to code something, it kind of gets it wrong, you tell it to fix it, and you just repeat that cycle. The AI has no big picture. But with the new, spec-driven way, you're doing the thinking up front. You define everything first, which gives the AI a crystal-clear guide, and the result? Code that's predictable and high quality.
Okay, so that all sounds great in theory, but what does it actually look like when you sit down to work? Well, it all begins with how you structure your project. A clean, well-organized monorepo, that's a single home for all your project's code, is the absolute foundation for this whole thing.
And this is a perfect example of what that structure looks like. You've got your front-end and back-end folders, nice and separate, but look at the really important parts. That specs directory, that's where your blueprints live, and that claw.md file, that's like the master plan. This setup gives the AI a complete map of the entire project.
Now you can even level this up by using a framework like SpecKit. Just think of it as a simple set of rules for your specs folder, and just look at the difference it makes. Instead of just a jumble of files, your specs are neatly organized by what they are: features, APIs, database schemas. This isn't just to make it look pretty for you. It's absolutely essential for helping the AI find the exact piece of information it needs right when it needs it.
So we have our blueprints all organized in the specs folder. Awesome. But how do we tell the AI how to actually read and use them? That is the whole job of those claude.md files we saw. They're like little instruction manuals that you place in key spots around the project. The one at the very top, the root clclaw.md, is the master plan. And I don't mean just a vague description. This is where you write concrete instructions. You'd say something like, hey, this is a full-stack app using Next.js and Fast API. The single source of truth for everything is in the /specs folder. So when I ask you to make a change, I want you to first update the spec and then implement the code in both the front end and back end to match that spec. And then you get more specific with layers of instructions. Inside the front end folder, you'll have another claude.md file with its own rules. Like, okay, in here, we're in a Next.js app. We always use TypeScript, we prefer server components, and all styling has to be done with Tailwind CSS. And then the backend has its own file with its own rules. This is a Python app with Fast API. All API endpoints have to return JSON. This layering is so important because it prevents the AI from getting confused and, trying to use a Python library in your JavaScript code or something.
All right, let's put this all together and see how it works with a real-world task. We're going to tackle a feature that is super important and touches both the front end and the back end: user authentication.
So here's our problem. Our Next.js front end speaks JavaScript, but our Fast API backend speaks Python. They're totally separate. How does the backend have any idea who is asking for data? And how can we make sure that users only see their own stuff and not someone else's?
The answer is a well-known industry standard: JSON Web Tokens, or JWTs for short. It's actually pretty clever. When a user logs in, the backend gives the front end a special, digitally signed token. You can think of this token like a temporary digital passport that proves who the user is on every single request they make after that.
Okay, so here's how that actually works, step by step. The user logs in and they get that token back. From then on, the front end attaches that token to every single API call it makes. When the back end gets a call, it looks at the token, checks to make sure it's valid, and if it is, it knows exactly who's calling. This is what allows it to go to the database and say, okay, only give me the tasks that belong to this specific user.
And this right here is where the true magic of this whole approach kicks in. Because we have specs for how our authentication should work, how our API should behave, and what our database looks like, we can ask the AI to implement this entire complicated feature across both the front end and the back end all in one shot.
So let's just recap the huge wins here. First, the AI has a single context. It sees the whole project, so it can make intelligent changes to both the front end and back end at the same time. It's not guessing, because it has those layered instructions guiding it. And that specs folder, it becomes the undeniable source of truth for everyone and everything working on the project. The result is a code base that stays clean, organized, and way more predictable.
I think this quote from the source material just sums it up perfectly. On the surface, the API looks the same, but under the hood, something fundamental has changed. Every single interaction with the backend is now secure and specific to the user, all because we gave the AI a clear blueprint to follow.
And that kind of leaves us with a really interesting question to think about. As these AI coding assistants get smarter and more capable, is it possible that our main job as developers is going to shift? Maybe less about being the expert coder who writes every line, and more about being the expert architect who designs the perfect blueprints that guide our AI partners to build whatever we can imagine.